This is my cat, Matilda. It can move on 3 axes, left and right, forward and backward, up and down. But there is one more. Time. A century ago, physicist Albert Einstein suggested that our universe consists of a 4-dimensional structure called space-time. To visualize this, let's imagine that there is a grid everywhere. Then every object that has mass or energy distorts it. He calls this curvature gravity, and the more energy or mass is concentrated in the area, the stronger it is. To simplify things a little bit, let's consider a grid as a plane. Now let's look at Earth orbiting the Sun. In fact, our planet is moving straight, but the distorted space causes it to change course, which looks like rotation around the star. You can think of it as walking on the surface of a sphere. You go in a straight line, but eventually you end up in a circle. The same thing happens with light. When it passes by some really massive object like a black hole, it gets distorted and we can observe this strange effect. This is called gravitational lines, and it can sometimes act as a magnifying glass, helping astronomers see more distant galaxies. However, on September 14, 2015, the LIGO Observatory directly detected the gravitational waves coming from the merger of 2 black holes for the first time in history. That revealed gravitational waves astronomy. But what are gravitational waves? Well, look at this rock. When it falls, it creates ripples. Similarly, when a large-scale event such as star exploding or galaxies colliding occur, the fabric of space bends and generates these gravitational waves. And how did researchers detect them? Well, they used a thing called an interferometer. In fact, it's a laser beam divided and directed into 2 equal arms with lengths of 4 kilometers each. When a gravitational wave passes, it stretches and compresses them, so a photodetector can record this difference in the distance that light travels in each tube. Why do gravitational waves matter? Because electromagnetic radiation that was commonly used to explore the universe has some disadvantages. It can be scattered or completely absorbed. Gravitational waves interact only weakly with matter, so they move freely through space. This allows scientists to build detectors which are directed not to a point, but to the entire sky, and peer into the most inaccessible places such as the core of a neutron star or the center of a galaxy. We can also see further back in time than with electromagnetic radiation, as early universe was opaque to light but transparent to gravitational waves. The invention of the telescope has expanded the possibilities of mankind to explore the cosmos, but now we are on the threshold of a new era, and who knows what we are going to find next.